Turbine lubrication system, ring oiling and circulating system. Here we are showing typical thrust bearing. Lubrication of the steam turbine is required to minimize rotating friction in journal bearings, thrust bearings and reduction gears, as well as to cool the journal and other bearing surfaces. Heat from hot parts of the turbine is also transferred from the shaft to bearings. Heat thus transmitted is carried away by lube oil, thereby maintaining bearing temperature at a safe level. Depending on the size and type of the steam turbine and also on their age, the lubrication systems of steam turbines vary widely and may fall into either one or a combination of a ring oiling and circulating system. Request: it is hoped that this session is going to be useful to you. Please press like button. Please subscribe. बहुत जल्दी यह लेक्चर आपको हिंदी में भी उपलब्ध होगा. Ring oiling. Here we are showing typical journal bearing. In small turbines, the oil quantity required for lubrication is small and the supply system is relatively simple. A ring rides loosely on the journal and its lower part dips into the oil reservoir. As the shaft rotates, the ring revolves and correspondingly oil from the reservoir clings to the ring and is carried to the top of the journal, to which it transfers by direct contact. Grooves in the bearing permit the oil to travel in axial directions and provide proper lubrication at bearing areas along the length of the journal. Excess oil drains back to the reservoir beneath the bearing and aids in cooling the journal and bearing. In small turbines, the surface areas of the reservoir are large enough to radiate this accumulated heat and maintain the oil at a safe temperature. For some turbines, it is necessary to cool the oil by passing the circulating water through a chamber adjacent to the reservoir or through a coil immersed in the oil. Pressure circulating systems. In larger units, the need for greater oil flow and larger heat dissipation dictate the use of oil circulating system. During normal operation, the main oil pump mounted on and driven by the turbine shaft draws oil from the main oil tank and discharges it at a high pressure to the bearing lubricating oil system. The lubricating oil pressure is usually maintained constant at about 100 to 150 kilopascal depending on the particular turbine and bearing design. During the starting and stopping operations of the turbine, when the rotor and main oil pump are not up to the rated speed, an externally driven auxiliary oil pump is needed to supply the oil. The main oil tank is equipped with vapor extractors to keep the oil tank atmosphere free of oil vapor and strainers to arrest suspended impurities. Oil used for the bearing lubricating oil system is cooled in the turbine oil coolers to control the bearing oil/metal temperature. Thereafter, oil passes through the oil filter to supply dirt-free lube oil to the bearings. The oil that has passed through the filter is then led to bearings via a lube oil pressure reducing regulator. From the bearings, the lube oil drains back by gravity to the main oil tank, where any heavy impurities that may have been picked up tend to settle out. Some form of oil cooling is found in all lubrication systems. While direct radiation, water jackets, and simple coils are common in small turbines, separate oil coolers are usually used for circulation systems. They serve to remove the heat developed in bearings that in turn maintain low lube oil temperature and retard oxidation of oil. Excessive cooling of the oil, however, is detrimental as it causes precipitation of soluble products of oxidation in oil cooler tubes. The water pressure is maintained less than the oil pressure so that in the case of a leak, no water will enter the oil. Circulation systems are designed with the main oil pump for bearing oil supply that is driven from the main turbine shaft. Auxiliary oil pump for lubrication when the turbine is not up to the speed are usually the motor driven type. The auxiliary oil pumps are particularly useful during starting and stopping of the turbine. Request: it is hoped that this session was useful to you. Please press like button. Please subscribe this channel. बहुत जल्दी यह लेक्चर आपको हिंदी में भी उपलब्ध होगा.